So, Renny, we're going to talk about rectifiers today. I know that's a very much top of mind topic to a lot of finishers who are looking really to, upgrade the real heart and soul of their systems and everything. And tell us about, like I said, with Hendor and plating equipment. This is something that you all supply to the industry as well, correct?
Yeah, absolutely. Hey, Tim, first I'd
Yeah.
like to say thank you for having me and
Sure.
everything you do for the industry.
Thank you.
So,
Yeah, sure,
so
certainly.
anyway, I work for two companies,
Hmm.
Hendor and Plating Electronics, and today we're going to talk about Plating Electronics, the rectifier side.
Gotcha.
So you said, what types of rectifiers does Plating Electronic offer to the industry? Well, for
Yeah.
51 years, Plating Electronic has offered industrial DC rectifiers and pulse reverse power supplies for the electroplating and surface finishing industry, and which
Hmm.
includes laboratory, general metal finishing, printed circuit board, anodizing, e-coating, water treatment process, uh, electrolysis applications, and hydrogen production. So it's a pretty big range there, is what you can see.
Right.
Uh, and
Yeah.
and and globally,
Yeah.
our rectifiers are known for precise current control, reliability, and long service life. And I'd like to just
Hmm.
comment on where our manufacturing and engineering is at.
Sure. Yeah.
So our engineering and manufacturing is located in Germany. And from the beginning, our niche in this industry has been providing solutions with high quality DC rectifiers and pulse reverse power supplies with advanced controls. And what I like to say in that very, very beginning, since the beginning, 51 years ago, we've been, I know
Hmm.
switch mode has really gotten big the last 20 years, 30 years, we'll call it, whatever. But for 51 years, we've been doing switch mode technology. So we
Mm.
started out with switch mode technology. So we've been doing that for 51 years. Our equipment within the United States is supported by PE in Germany and Hendor-pe, which is based in Greenville, South Carolina, representing both Hendor and Plating Electronic.
Right. Yeah. Yeah. You have your headquarters in South Carolina. You're in Michigan, I correct? I
I'm
believe
located
correct,
in
right?
Michigan. Yep, that is
Right.
correct.
So you can get anywhere in a day if you needed to, pretty much.
Yeah, I'm about, at least that's what they say. It depends on the
That's what
airlines,
they
but yes,
definitely.
I'm about 40
Yeah.
minutes, just calling an hour from Detroit.
Right. Yeah. Yeah. I didn't know you all had been doing that. Plating electronics had been doing that for so long with that. That's interesting about that. Have really engineered a lot of this technology, I'm sure.
Yes, for precise current control, right? That's really what their niche was. That's what they got into, is really help the PCB industry out with
Mm-hmm.
pulse reverse. And we'll get into talking about the different types of rectifiers we provide as well. But so yeah, they've been doing it a very long time. So it's not new technology. It's been around, but it has changed for 51 years. You can imagine with technology, a lot of advancements has happened, and a lot of the processes today for end users have changed as well.
Right. Yeah, definitely. Yeah. Like I said, yeah, I think it's three different types, right? Go through those for me if you could, of what the different types are and all
Yeah,
that they
yeah,
do with that.
yeah. We have SCRs, which is an older technology, switch mode technology, and then you have the pulse and pulse reverse.
Hmm.
And then I'll
Okay.
just kind of highlight on each one of them.
Sure. Yeah. Please do. Yeah.
So SCR rectifiers are we'll say they're best for heavy duty, high current process such as hydrogen production or plating
Hmm.
applications where higher ripples don't seem to matter, or
Hmm.
energy efficiency doesn't matter. SCR technology is an older technology that requires much larger footprint as well compared to
Hmm.
switch mode technologies. And depending on our SCR models, ripples range from 2.5 to 5%,
Okay.
where switch mode technology is less than 1%. So what does that mean when we say ripple?
Hmm.
So
Hmm.
what low ripple is a means cleaner, pure DC current that provides a more even plating distribution.
Hmm.
High ripple can cause bad plating adhesion. So that's the variance there. So you can imagine over time. So with that, you get less rejects, less rework, et cetera, more quality for the customer, and also you can control the metal that's being deposited onto the product instead of trying to guess. And let's say the SCRs, you would go over if they request this thickness, you would make sure you go over the limit. But you can go with the switch mode technology. You can monitor it in precise current. You can get it dead on.
Right.
So switch mode. So being that we talked about switch modes, there, switch mode rectifiers are best for precision plating, electronics, or where energy efficiency and tight control are important. Switch modes are an excellent choice for multiple plating cells with controlled recipes or precise plating thickness. The benefits of a switch mode rectifier, which are a much smaller footprint.
Right.
They're being that they have a smaller footprint, you can do modular designs up to 10,000 amps. If in parallel, you can do 10,000 amps plus if run in parallel.
Yeah.
And like I said, the smaller footprint allows space savings, standalone power supplies. We offer standalone power. They offer, I guess I should say, they give you a nice space savings. You can do them in a standalone next to the plating processes, or you can put them in a remote area. You can group them together for individual control when you have more than one plating cell. As I said, switch mode ripple is less than 1%, providing cleaner, purer DC output for more uniform plating on the substrate. Switch modes reduce part burning and plating roughness, resulting in fewer rejects. Switch mode technology converts power more efficiently. So what does that mean? More of the AC input power is used for the plating process, which yields less energy, reducing electricity consumption, which is huge today. If you have a lot of rectifiers in your facility, and most job shops do, right? A lot of energy there, and it's just not the rectifiers. They got their whole facility with energy there. So it becomes very important for cost savings moving forward.
Gotcha.
And again, SCR technology is much older technology and often requires an oversized rectifier because of the higher losses, which need extra current capacity for stability and peak demand. Switch mode technology delivers more stable, cleaner current, which allows you to size the rectifier closer to the process requirements.
Right.
So you don't pay for more. Is what basically you can size it a little bit more, so you're not paying for more. Is what I'm saying, and also the footprint gets a lot smaller for you.
Right. Yeah. Really, the efficiency, like I said, this is which is when people are talking in certain parts of the country where electrical costs are very high, very very high, and this really is going to save them money in the long run. I would seem with reduced costs in that area.
Yeah, I'm glad you said that. I got an example here. I worked with a client here that had 20 plating cells, and he had an automated hoist line with 20 plating cells, and they run it. It was old SCR technology, so if you can imagine, huge, bulky rectifiers at each station, and then they had some on a mezzanine, and he wanted to upgrade, and we talked him into some switch modes, water cooled. So we got the water cooled over the air cooled, and what we were able to do is reduce the actual footprint. We were able to reducing the footprint, we're able to also size the rectifiers more closely to his plating requirements, which the energy alone there, he was able to save quite a bit there. So he reduced the overall energy consumption, the kilowatts. And what we did, we figured out what the savings was on the 20 rectifiers. And I won't say the amps or anything what we went through, but the number was roughly $15,000 per year in just energy consumption saving, which is not a small number. That's a big return on investment right there, right?
Right.
And then if you control the rectifiers in a manner that are controlled, right? Don't let them, like, there's a bunch of air-cooled rectifiers that suck in a lot of air fumes and stuff like that. They don't last long. They decay. Where the water-cooled ones, if you properly do the water, we got rectifiers since 51 years ago, switch mode technology, that are still running today. Right. So they can last a long time if they're properly taken care of. And it's kind of like your car. People say, well, how long does a rectifier last? Well, if you don't take care of your car's not going to last very long.
Right. Exactly.
Right? So if you take care of your rectifier, it'll last you a long time. And part of the process is we go through asking customers, where they put in the rectifiers. We ask a lot of questions before we get into rectifiers because we want to help the customer so they have that longevity.
Yeah, like I said, it's and I've seen that a lot more where I'm seeing where these rectifiers are. It's the plating operation is a very corrosive environment, right? Where they're now able to kind of put those somewhere outside that environment, right? And is that what you're seeing more of these days with that, or
Yeah, the footprints are, you got to feel real estate in a plating organization
right?
is usually very tight,
Mm-hmm.
especially job shops. They have multiple machines, and even if it's not a giant captive shops, they squeeze everything in. And rectifiers, they usually put right near the plate tank just due to the fact that the busing, it's very short. So there's a cost there for busing.
Mm,
Uh, and like you said, it's very corrosive. So the old technology, SCRs the fans would bring all those fumes inside the
right,
corrosiveness and start to deteriorate the rectifiers. Where
right,
water cooled
right.
ones, you don't have that problem. You can put them still close to the machine. Uh, I even would suggest a couple of things like put some PVC walls, barriers, to try to help protect them, get some ventilation in there, try to
Exactly.
protect
Yeah.
them. But really, you're just helping them from decaying. But the water cooled ones will if you run them at the optimum temperature, they'll last you a very long time, just like your cars.
Right. Yeah.
It,
It's
it, it,
funny. Yeah, I was gonna say these are very technology advanced, right? With that, what's the learning curve? When you bring in some newer equipment, and what's the learning curve for a plating team to really grasp what this can do and to understand it and to run it themselves? Is it that long, or is it something that it's pretty obvious to them, or how does it work?
no, it's pretty much if they're plating, they understand it already. So it's
Hmm.
pretty simple going from an
Hmm.
older school technology to a newer. But where the learning curve is going to be, there's some energy or cost savings, and they can get into precise plating control for the customers based on
Right.
how many plating cells they got. So older technology SCRs, you would bust the whole tank for let's say 10,000 amps, and then you
Mm.
turn it on, and then basically that's how your current gets distribution. Right now, you
Mm.
can control each one of those plating cells individually and control it based on plating thickness, right? And you can do it
Right.
by how many parts for your recipe, or you can do it based if it's a barrel, you can do it based on barrel weight.
Mm. Gotcha. Gotcha. Yeah.
Okay, so you can really control it. So if you think of it in an automated line, you barcode the customer's product going in, and the recipe's there. It goes into that plating cell, and the amperage already adjusts to what it needs to, and it kind of times out at the duration. And in an automated world, it'll time out and go into a trickle charge because if you shut it off, it'll kind of deplate itself. So it goes into a trickle charge, and then basically it waits to its time and pulls out. So you have that
Gotcha.
you're not overplating the product, is what I'm saying.
Right. Definitely. Yeah. Yeah. I was going to ask you, I guess, this is really, like I said, in the last 10, 15 years, really some technology. The technology has really, improved a lot with that. And like I said, especially with, we think of, products coming out of Europe and Germany, like with plating electronics that, it's a little bit more, it seems to me, always seems like a little bit more advanced in Europe than it is here. And then it comes here, people try to, but it seems like, like I said, this is something that has really, kept up with what needs to be done. Like you said, of giving more control, right? More really dialing this technology into what's being run in the shops. Then I guess, right?
Yeah, yeah, and you said it right there. So really, what you're seeing, customers today are moving toward a higher energy efficient, tighter process control, and smart digital features is what they're looking for, right? So
Mm-hmm.
this is including pulse capabilities, automation, integration, remote monitoring, industry 4.0, and basically to improve quality and reduce operational costs is what
Mm,
that does.
gotcha. Yeah, yeah. I was gonna say, and really, I mean, a lot of this, I'm sure, has come out of from the plating shops and the finishing operations, really asking for some of this technology. And like you said, you all are pretty much industry innovators in this. Is that pretty much what a lot of the shops are asking? The end users are asking you all to really help them become more efficient. Reduce some costs. Like I said, with energy, I've often heard, you know. Shops tell me the most expensive things is water and electricity is what they're spending a lot of money on, but helping them to reduce those costs, but also uh, get some cost savings, uh, which turns into a pretty good ROI with these.
Oh, absolutely, and that it does. It gives you the cost savings that you're looking for, and the energy efficiency. It saves, like I said, some real estate. It gives you flexibility to mount these pretty much where you
Hmm.
want, right, in the
Right.
facility. Um,
Right.
I
Yeah.
forget what else I was going to say there.
Yeah, I was going to say, and like I said, that's where really the I know you know you spent a long time of your career of designing these designing systems and shop these shops going in and helping them. Is that something a lot of shops have top of mind, that they probably need to look at their electrical system, the rectifiers and things like that, or is it just a lot of people just it works, we'll leave it there? But is it something that is really on their top of mind, that they're looking at when they go in and look for improvement? I know they talk about motors and hoists and things like that, but really the rectifiers seems to be the heart of the system to me.
Yeah,
It seems like.
yeah, rectifier, and they're a big chunk of the money of the system too.
Mm,
I don't know what that ratio is, but if providing automated systems, rectifiers were always a big cost to the system, right?
mm,
But yes, that is customers are looking. They want high efficiency motors. They want everything to be high efficiency. They want state of the art equipment. If they're looking for new equipment, they want state of the art equipment, and they want all those energy saving devices, right? So I would be looking for calculations on what I could save if I was looking for a new machine today. What is
right.
my savings compared to what I'm doing now to get that return? And I'm sure they're all doing that as well.
Right, right, and plus, like I said, with you all with the Hendor, you got the pumps, you've got everything. You can really bring a system back to life and get it running the way it should be running. I know some of these lines I go into, they're decades old, seems like sometimes, and really it is to have maybe you come in and look at the rectifiers and the pumps and everything and see how that's all working, so you can really fine tune these systems so that they're putting out they're reducing rejects, right, they're reducing those costs, but also, like I said, from an operational standpoint, using less water and using less electricity. It seems to be a big win for them in the long run.
Absolutely. And the last
Yeah.
topic was pulse and pulse reverse to talk a little bit about here.
Hmm.
So pulse and pulse reverse are an excellent choice when a complex process is required, and this is forward and reverse plating. Forward meaning a plating phase, and reverse meaning stripping and cleaning the
Mm.
plating deposits for more uniform plating.
Gotcha.
So today, and today, if you look at electronic boards, are getting smaller and thicker. Thicker boards plus smaller holes make it very
Mm.
challenging for current and chemicals to reach the center of the substrate, right?
Right. Mm.
Uh, this is when you need a good pulse reverse power supply with good waveforms to achieve a more even copper plating deposit.
Mm. Gotcha. Yeah.
And then I was going to say just pulse reverse power supplies are high efficient, energy efficient with a ripple less than 1%. And we've always
Gotcha.
provided that in a switch mode technology.
Right.
Our pulse reverse provides precise current control, very fast switching between forward and reverse, reducing energy consumption. Switch mode technology are more compact and modular. Our pulse reverse are very reliable and designed for continuous operation.
Mm. Gotcha. Yeah. Well, like I said, just very, like I said, very much. I hate to use the word state of the art because it's always used, but very much the latest technology, especially since, like you said, some of those challenges that are coming up with, that you mentioned with the boards and such, and it seems like, but with the rectifiers that you all have are able to sort of meet those needs, meet those challenges that might be presented with that. So.
Yeah, absolutely. We've been doing some testing with some people, so yeah, we've been asked to push the limits as well. So it's interesting, especially as the boards get thicker and thicker.
Gotcha. Yeah, definitely, definitely. Well, listen, again, I want to appreciate you stopping by and talking to us about this. I know it's something that's very much top of mind, again, to a lot of finishers who are looking for, upgrading their equipment, but also surprisingly realizing some cost savings, like you mentioned
Yeah.
with the electricity, and also some space savings, which is crucial as well when you get some of these shops. But I do appreciate you taking time out and explaining this to us, and people can visit you all's website of Hendor and Plating Electronics to get more information. But Renny, I appreciate it. Thank you very much, sir.
Hey Tim, thank you and have a great day.
Mhm.